Good day, students. So on this clip, we're going to be going over an example on how to find the angle between lines on a plane. So let's go ahead and write down the instructions for the notes. So the instructions are as follows. Find the acute angle. The acute angle between the given pair of lines. Okay. So the lines that we have are, for number one, we have 3x plus y equals 6 and 2x minus y equals 7. Okay. Now the whole idea we're going to basically use the idea of using two vectors that are parallel to these lines and finding out the angle between them. Okay. So let me give you a visual as to what I'm talking about. So let's say we have okay. Let's say we have a plane of this nature, and then we have two lines on it. Okay, we have two lines on this plane. There goes the first line, and then we have another line. So all we need to do is we just need to find two vectors that are parallel to these two lines, and the angle between those two vectors will basically tell me what the angle between the lines are. So this is L1 and L2. So all I just need to do is find two vectors, okay? So let's say we have from here one vector going in that parallel to L1, and then another vector parallel to L2. So if I can find the angle between these two vectors, that will basically tell me what the angle is between the two lines, okay? So this is theta right here, and then let's call this V1, and this is V2, okay? The reason why I'm using vectors is because there's a cool formula that we can use to find the angles between two vectors, right? The formula is theta equals the inverse cosine of the products of the vectors v1 dot v2 divided by the respective magnitudes. The magnitude of vector v1 multiplied by the magnitude of vector v2. Okay, so this basically helps me figure out what theta is. Alright, so I reduce finding the angle between two lines is just reducing it into finding the angle between two vectors that are parallel to the respective lines. Okay, so that's what we're going to do. Alright, so now let's take a look at the problem. All I just need to do is I just need to find a vector that's parallel to the first line, and then the vector parallel to the second line. Okay, so I'm going to call this line, let's call this line 1, and then call this line 2. So in order to find a vector that's parallel to line 1, I need to first of all find the slope, and that will tell me the direction of the vector that's parallel to this. So the slope of line 1, m1, is going, since this is in standard form, I'll use the formula negative a over b. That's the quickest way, or you can get y by itself and find m, same procedure. So negative a over b is going to be negative 3 over 1. Okay, so there's a slope. So this tells me that this is a movement in the j direction, and this is a movement in the I direction. Alright, so vector v1, which is a vector that's parallel to line 1, is given by 1i, which is just I hat, minus 3j. Okay, using this slope. This is the I directional movement, which is down, and this is the j directional movement in the j direction along the y-axis, and this is the I directional movement along the x-axis. That creates that vector for me. All right. Next, we need this vector v2. So to do that, I just need to find the slope of the second line. Let me partition my workspace here so that we do not get confused. Partition that like that. Okay, so now I'm going to look for m2. So let me just indicate what I did earlier, that this is for my I, and this is for my j. Okay, so for the second line, to find the slope of the second line, since this is in standard form, I will employ the shortcut negative a over b again. So negative a is going to be, this is a, oh, and this is b, okay? So negative a over b is going to be negative 2 over b is negative 1, which is 2, okay? 2 over 1. So, as we mentioned before, the numerator of the rise is the movement of the vector in the j direction, and that's not how you write j, is it? No, I'm writing my j and I got my j and my i's confused. Anyway, this is the movement in the j direction, and then the denominator, the run along the x-axis is the movement in the I direction. Okay. All right, so we're going to create vector 2 using that information. So v2, vector v2 is going to be I, 1I, you just write it as I, there's no need for 1, plus 2j. Okay? So there goes your two vectors that are parallel to these two lines. So now with that in mind, what we're going to do is find the angle between v1 and v2, and that will tell me the angle between these two lines. Alright? So we're going to use the formula that I stated here, theta equals the inverse cosine of v1 dotted with v2 divided by the magnitude of v1 times the magnitude of v2. Okay? So that's how we do it. Alright, let's plug it in. Plug in vector v1, v2 into this formula and compute the angle. Okay, so we're going to have the inverse cosine of, let me make that a bracket. We're going to be doing some nesting here. So of bracket. So v1 is I minus 3j. That dotted with the v2, which is I plus 2j. Okay, that goes for the numerator. And then in the denominator, we're going to be multiplying the magnitude of each vector. Okay, so divided by the magnitude of vector v1, which is I minus 3j, times the magnitude of vector v2, I plus 2j. Okay? Alright, let's find the dot product of the numerator first. To find the dot product of the numerator, we'll just multiply corresponding components and add the product. Okay? So, bracket again. I times I, we just multiply the coefficients of the components in each direction. So 1 times 1, 1 times 1, plus the product of the y components, or the j components, is going to be negative 3 times positive 2. Okay? So that's the dot product of the numerator. Now in the denominator, we're going to use the Pythagorean theorem to find the magnitude of each vector. So we're going to find the square root of the sum of the squares of the coefficients of each component. So square root of 1 square plus negative 3 square. Okay? That's for the magnitude of v1. And for the magnitude of v2, the square root of the sum of the squares, 1 square plus 2 square. Alright? Okay, now let's simplify further. We're going to have the inverse cosine of, in the numerator we have 1 plus, actually 1 minus 6. 1 minus 6 divided by the square root of 1 plus 9 times the square root of 1 plus 4. Okay, so now we have the inverse cosine of 1 minus 6 is negative 5, divided by the square root of 10 times the square root of 5. Okay? Now, since cosine is an odd function, this minus, so I can drop the sign. So we're going to have the inverse cosine. We're looking for the acute angle, okay? So we're just going to be restricted to the first quadrant. So we can drop the sign, becomes 5 over the square root of 50. Okay, so there goes what theta is. Alright, so let's simplify this a little bit further. There are two ways we can do it. I can express the top as a square root and then just divide, or I can rationalize the denominator. Let's reduce root 50. So we know that root 50 is the same thing as 5 root 2, right? So using that fact, this is going to be the inverse cosine of 5 over 5 root 2. Okay? And that reduces to the inverse cosine of 1 over root 2. Alright? And we all know what the inverse cosine of 1 over root 2 is, right? It's basically pi over 4. Alright, so that's basically what theta is. Alright, so it's pi over 4 radians, or same thing as 45 degrees. Okay, so let's just verify that. You can use your calculator to verify that. This is a TI-89. It can help me compute exact values of common angles. So let's see, we're looking for the inverse cosine of 1 divided by the square root of 2. Inverse cosine of 1 divided by the square root of 2. Radian answer is pi over 4, and that's basically 180 divided by 4, which is 45 degrees. So that shows that our answer is correct. So the angle between the two lines is basically 45 degrees. Okay, so there you have it. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel just by clicking up here. More videos can be found on Math Circle.